All right, today we got similar solids. So these are going to be solids that have a certain scale factor between them. So like we could have, for example, two cubes, and we'll kind of talk about the different properties of those cubes there when they are similar here. So in similar figures, the relationship between the scale factor and the perimeter, we learned that that was the same, or those were equal to each other. If you think back to our lesson where we did the little SPA charts, we went and said, for example, if you had like 5/2 for your scale factor, we said the perimeter still had that same ratio, 5/2. And then we learned that you go and square your area ratio. So we would say that'd be 25/4. That'd be squaring both pieces there. All right, so what's different about today is now we're going to talk about the volume in addition to all that stuff. So typically volume is cubed units there. So what we're going to do is we're going to take our scale factor and then we're going to cube that. So we would have 5/2 cubed, which would get you 125/4, or actually over 8. All right, and then so yeah, let's go ahead and fill out a couple things here. Scale factor, we've already defined that in the past, but we can just say it's the ratio between two sides, I guess, of a figure. And typically we want to say that it's the new over the old to get your scale factor there, and that'll tell you, if it's increasing or decreasing in size. All right, you also have the scale factor here. It's the scale factor, I guess, here is A to B, determine the area ratio. So like we said up there above, you're going to square the area ratios, and the volume ratios, we're going to cube those. All right. Now we got this one right here where they give us a scale factor, so I guess we're going to find all the different ratios. So we're actually using numbers here. So if you have the perimeter, or if you have the scale factor is 2/3, the perimeter's got to be the same. So that'd be like, maybe the perimeter of the bases or something like that, since we use that for our formulas. The area ratio, you're going to cube those or square those things, so that'd be 4 and then over 9. And then the volume ratio, you're going to cube the 2/3, so that would be 8/27 when you cube those. And you got to be careful. Sometimes I'll have students that will want to take your area ratio and then square that, so it's like you square twice. So I'll have some students put something like, I guess, 16/81. So you got to be kind of careful. You're cubing the scale factors. So be kind of careful there on that. All right, every now and then they'll give us the area ratios, and maybe we'll need to work backwards to go find either the scale factor or the perimeter, all that stuff. So the area ratio is 16/49. So we know typically our area is the squared stuff. So we're going to do the opposite. We're going to square root those. So that would get you 4/7 for your scale factor. And then after that, we can go and say the perimeter has got to be the same. And then the volume, you have to cube that. So 4 times 4 times 4 is 64. And I think 7 times 7 times 7 would be the 343. All right. Next, given the volume ratio, find the scale factor, perimeter, and area ratio. So some of you guys are probably thinking, well, okay, if they give me the volume, then I need to do what's called a cube root of both of these things here. But the issue is 16 is not a perfect cube and 3 is not a perfect cube. So actually what we're going to have to do first is we need to go and reduce this thing. Now if it doesn't work, then I guess you're just going to have some decimals or some radicals with your answer here. So when we reduce it, you're going to get 8, and then I think 54 divided by 2 as well, that'd be 27. We actually can do the cube root of 8, which is 2, and the cube root of 27, that's 3. So we can say scale factor is 2/3, perimeter is 2/3, area is that square, so 4/9. That's kind of what you do there. So you got a cube root both of those. So let's next one right here is just determining if the scale factor is the same, and then if something is similar or not. So if these dimensions have the same scale factor between each other, then these are similar objects here. So first of all, I'm going to check the radii. That's the plural for radius. So we're going to go new over old, so we'll say 5 over 3, and that doesn't reduce there. And then now we'll go and get the heights. The heights, you have a 10 to 4 ratio, which reduces down, and that'd be 5 to 2. So notice that your two different scale factors between the dimensions are a little bit different, so we're going to say that these cones are not similar. Okay, number 2, kind of the same thing. You got, I guess, radii and then your heights. So we'll do the heights first this time. The heights, you're going to have 15 over 7.5. And if I want to get that reduced, that actually reduced down to 2 over 1. 7.5 will go in twice. Now if I go back and I do the radii, you got to be kind of careful here, because a lot of you guys are going to see that 5, but then some of you guys are going to put 5 over 5. And you got to pay attention. This one here on on the smaller one, I guess, they give us the diameter, so we need to go half of the diameter, so that would be 2.5. And then that would also reduce to 2 over 1. So these cylinders are going to be similar. That's all you do there on that one. Now, next one right here, we'll actually use our different scale factors and area ratios. And we'll go and figure out, sorry, it's looking there. We'll go and figure out what the new surface area, or maybe the new volume, would be. So, sometimes the numbers get a little big here, so I'm going to get that pulled out in front. So here's the thing. They tell us the scale factor between these is 2 to 5, so maybe that's the ratio of the heights, and then actually could say it's the ratio of the radii as well. So we're going to make an SPAV chart, so we're going to put all that there. We're going to say the scale factor is 2 to 5, and actually we'll say 5 to 2 since it looks like it's getting bigger. So we'll go 5 to 2. That means the ratio of the perimeters, which we call that the circumference here. That's also 5 over 2. And then the areas, you're going to say it's 25 over 4 because you got to square it. And then volume, you want to cube it. And remember, you want to cube the original scale factor. So that'd be 5 times 5 times 5, or 125, and then over 8. Okay. So if we're trying to find the new surface area, notice they gave me the surface area of the smaller object, cylinder A. So we're going to go ahead and use that information. We're going to say that we're going to use the area ratio first. So we'll say 25 to 4 equals, and then they gave us the smaller one, so I'm going to put that in the denominator. So I'll put the 96 pi in the denominator, and then I'll just put SA, I guess, at the top, so we can keep everything sorted. So that's the surface area there. Okay, so when you cross multiply, you're going to have 4 times the surface area. I'm just going to use A actually in this case. And then what you need to do is multiply the 25 and the 96, and then we'll just attach the pi to it. So that'd be 2400 pi. I wouldn't type out the pi button in your calculator because typically we leave things in terms of pi. So we got that, and then you go and divide, and you're going to get A that equals 600 pi, and then I guess it was feet, feet squared there. And that would be the surface area of the volume of the larger cylinder if the scale factor is 2 to 5. Now if you want to go and do the same thing and find the volume, you're going to use your volume ratio. So that'll be a little different. We're going to say 125 to 8. And then they gave us, once again, the volume of cylinder A. So that'll go in the denominator since that's a smaller one. So we'll put 128 pi in the denominator, and then I guess I'll put V up there in the numerator. And once again, you cross multiply and divide. That'll get you 8V equals the 1600, or 16,000, I guess, pi. And then remember, don't multiply by pi, keep pi in your answer. And then we'll divide both sides by 8, and you get 2,000 pi and then feet cubed. And that's how you find your missing surface areas and volumes. So number 2 here, kind of the same thing with some different numbers here. Once again, I guess they didn't give us original numbers here, but we got 2 cones, and they are similar. You got a 5:2 scale factor. So I think that means it's getting smaller, so we'll write it as a fraction 2/5. So we'll say 2/5, 2/5. And then the area ratio will be 4/25. And then the volume is going to be 8/125. Okay. Find the surface area and volume of cone B, given that the surface area of cone A is 2,356.2. Alright, and it looks like we are getting smaller here because you're going from 5 to 2, so we're going to assume that cone A is the larger one. So we'll use the area ratio at first. So we'll say 4/25, and then equals, and then we'll say, oh yeah, we were given the smaller one, or I'm sorry, we were given the larger one, my bad, 2,356.2, and then we'll put area up there in the numerator. Whenever you multiply it out, you're going to get about this right here, 376.99 centimeters squared. Then we'll do the same thing for volume. Volume, you use a different ratio, so just be careful with that. We'll go 8/125, and then equals B over the 7,450.9. Once again, it looks like they are giving us the larger one, and our scale factor says it's getting smaller. So you want the larger number on the bottom, smaller number at the top. You cross multiply and divide, you're going to get 476 and then 0.86. And then we'll go centimeters cubed for your volume. So that's it there. Not too bad. This next one here is kind of, I guess, a little bit tricky here. A store sells birdseed in 2 sizes of cube-shaped blocks. Smaller block measures 3 inches on one edge and sells for $1.99. The larger block measures 5 inches on an edge and sells for $5.99. So what I'm actually going to do here on this one is find the volumes of those cubes. The reason I want to find volume is that when you're selling something, we're not going to calculate the price based off of just a side length or the area of one of the sides. We want to know how much quantity we're getting inside. So inside of a 3-dimensional object, that's talking about volume. Alright, now sometimes volume can be like how much space it takes up. Sometimes stores will do volume by weight. So just kind of got to be careful and see what they're looking at here. So you might see like some type of problem that might kind of look like the same thing with weight. But anyways, so you got 3 by 3 by 3 and then 5 by 5 by 5. Which for the volumes, you just, it's 3 cubed essentially. So that's just 27. And then whatever the units are, I guess, inches cubed. And then the volume of this brick right here would be 125 inches cubed. So you get a significantly more amount of volume out of that one when you increase the sides there. So what we're going to do here, we need to figure out the unit price of both of these. So I don't know if you've seen at a grocery store, sometimes they'll have the main price, how much the object that you're buying costs. Especially at the grocery stores, but then there's a unit price in a little bit of a fine print. You kind of look off to the side and it'll be real small. So you can use that to figure out how much you're getting per 1 unit of that object or that food or whatever, drink or whatever it is. And so that's usually like in fluid ounces or regular ounces, like in weight or something like that. So anyways, to find the unit price, there's kind of multiple ways to do it. There's some people think about it logically. You can do the price divided by the volume, but what I'm going to do is show you where that comes from and set up a proportion. So I'm going to say whenever we get the 27, the volume of 27, inches cubed, birdseed, I guess, that was charging us $1.99 for that. So I'm actually going to use that as a ratio. I'm going to say 27 to $1.99, and then I'm going to figure out what do I get for 1 unit of that measure. So I'm going to say 1 over x, and then you cross multiply and divide. So we'll say that's 27x and then equals $1.99. So essentially, you take your price and then you divide by the units and you get the unit price there. So when I do that, $1.99, this isn't written in for whatever reason, you get about 7 cents. 0.07, that's about 7 cents right there for that cube, I guess. So this next one here, we got 125. So we're going to say the 125, that goes for $5.99. So we're going to say 125 divided by $5.99, and then equals 1 over x to find that unit price. Trying to find what 1 cost. All right, and then you cross multiply and divide. Essentially, the shortcut to finding the unit price is take your price and divide by the total volume, or how much you're getting in that object there. So when you do this one here, that's about 0.05 when you round up. So it's about 5 cents per cubic inch. So the better buy is whatever's cheaper, which that would be the one that's 5 cents right there. And that's typically how most things in life is. The more you buy, the better deal you get. So anyways, that's a little bit on unit price there. Kind of using your volume stuff. Okay. Next problem here is just kind of talking about non-proportional change. There's not really a rule or pattern to these typically, so we're just going to have to just go and find the two different objects, surface areas and volumes, and then go from there. So we have a cylinder with a radius of 4 centimeters and a height of 12, so I'm going to go ahead and just sketch one of those out here real quick. So radius is 4, and then the height is 12. So I guess the first step, find the surface area of the original cylinder. So I guess we're going to take a new cylinder and we're going to make it a little bit bigger. And we'll go and figure out those dimensions. So first of all, find the surface area of the original cylinder. Remember, surface area of a cylinder is 2 pi r(h) plus 2 pi r squared. So that'd be 2 pi r and then 4 times 12. And then plus 2 pi and then 4 squared. So then that would be, when you punch it all out, 128 pi in centimeters squared. So then they're going to go and affect the radius and height. So they say the height is multiplied by 3, so that'd give us 36 for the new height. And then the radius is multiplied by 2, so that'd give us 8 for the new radius. So then we'll go and take those dimensions there. I guess radius is 8, height was 36. And then we'll go find the surface area using the same formula for that. So we're going to go 2 pi, the new radius, which is 8, and then times 36. And then we're going to add on 2 pi and then 8 squared. Alright, and then when you do simplify it, you get down to 704 and then pi and then centimeters squared right there. So if we want to compare the different surface areas and see what type of ratio those have now, we can take those two right there and we can go 704 divided by 128 pi. What's nice about this is we don't have to really mess with the pi's because those are going to cancel out. And then when you reduce a fraction, you're going to get 11 over 2, which doesn't really play into the fact that we multiply by 3 and multiply by 2 for your different side lengths there, or I guess the height and the radius. So there's not really a connection there, and that's kind of the whole point of this. There's not a shortcut to go and find the new surface areas. Okay, you can actually go do all the same stuff with the volume, so that's what we're going to do here. I'll put VO for the volume of the original, and then we're going to say the formula is pi r squared, and then times the height. So let's go see what the original was. That was 4 squared times 12, which that's going to get us 192 pi, and then centimeters cubed. Okay, next one, volume of the new, I'll use a little n for that. Still pi r squared h, so that'll be 4, or I'm sorry, no, that'll be 8 squared. 8 squared times 36, and then times your pi. Then when you punch that out, that'll get you 2304 pi, and then centimeters cubed. And they ask us how is it affected, so essentially we want to compare the two. So we'll do 2,304 pi, and then divided by 192 pi. All right, when you reduce those, the pi's cancel out again. You do get 12 over 1, but still not a very strong connection with the 3 and the 2. Each problem will be kind of different, so you just got to be a little careful on those. So anyways, that is it for the